video, we'll start talking about the document for our final project delivery, that is the computer peripheral device design. This project has the intention to reinforcing the concepts learned in computer interfacing course. The main purposes is to design a peripheral device with a functional interface for HID device, which performs data acquisition using the USB interface for data transfer operation. Our firmware design will consider the use of two endpoints, one input for transactions and the other that means that we will use for reading information of the simple data, and the other is for the output, which the main objective will be to send commands for the data acquisition process. The criteria for this selection. And now for this project we had three options: the microchip, Cypress, and ATML. But we select to work with the PIC32 because we had more experience working with the PICs of the family of these PICs. And now we will talk about the schematic design.
For the schematic design, we decided, according to the project description, to use this design as follows. We have 4 deep switches that act as our control lines. We have 4 analog inputs and 8 digital inputs. We have 8 outputs that work for our display and the USB connection. As you can see, we're working with a PIC32 MX795F512L, and we're using Eagle to do this schematic. Here we have our bill of materials, which is roughly what it will cost to do this project. We consider the microchip, the PIC32 that we just showed, the 7-segment display, 2 USB cables, the deep switch with four switches, and jumpers to do the proper connections. Now for our firmware design, we have our device descriptor, our configuration descriptor, our interface descriptor, and endpoint descriptors according to the project description. For our device descriptor, the important point is the vendor ID and the product ID, which were provided by us by the professor. Our configuration descriptor, our main point is that we have one interface and the total length of 29 and the 50 milliamperes as a max power consumption. Our interface descriptor, we have 2 endpoints, which is one for input and one for output. And for our endpoint descriptor, we have the first one, which is the input descriptor, here x81, our input descriptor, and the second one, our output descriptor, 91. We also have our HID class descriptor, which tells us the HID functionality of this of the PIC. We have our descriptor size, the descriptor type, which is the HID class descriptor, and we have a report descriptor, which tells us the functionalities of the information of the data that we are going to get from the PIC. We have our digital input, which has a local minimum of 19 and local maximum of a usage minimum of 19 and usage maximum of 29, which is consistent with what we said before.
We can conclude with this project the importance of the firmware and hardware design to make a working application, in this case data acquisition. To accomplish this, we define the USB descriptor, in which we establish the characteristics of the peripheral device, such as the device configuration, interface, and also information about the device itself, and the endpoint descriptors. Also, the way the information is meant to be read by the computer and by the final user of this application.